Hello class, welcome to this video on 7.4 rectangles. So our essential question today is about the properties of rectangles. So how do we apply properties of rectangles to classify parallelograms and solve problems? Okay, so we know what a rectangle looks like. So what are some properties of the rectangle? So rectangle we know is a parallelogram. Okay, so it's a special type of parallelogram, a type of parallelogram with 4 right angles. Okay, so the symbol for that is, so this is the symbol for that, right? Now, because it's a parallelogram, that means it has all the properties of a parallelogram. So these are parallelogram properties. And this is a specific rectangle definition property, okay? That makes it specifically a rectangle. All right, so because it's a parallelogram, we know that the opposite sides are congruent. And then the opposite sides are also parallel. And we also know that the opposite angles are congruent because there are 90. We know that the sides next to each other, the angles next to each other are added to 180. They're supplementary, 90 plus 90. And we also know that the angles bisect each other because that's what parallelogram diagonals do. But in addition, the diagonals of a rectangle are also congruent. So that means that these lengths are all the same in a rectangle. So that is theorem 7.13. The diagonals of a rectangle. If a parallelogram is a rectangle, then its diagonals are congruent. So let's apply this property for example 1. So a basketball team is running a drill along the diagonals of the court. Given rectangle BCDF, if FC is 106.5 feet, find DG. Okay, so we know that FC, because it is 106.5, has to be congruent to BD, the other diagonal, because it's a rectangle, according to theorem 7.13. So therefore, FC is congruent to BD. And so FC equals BD by definition of congruence. And BD is 106.5, since FC is 106.5 by substitution. Now, because it's a rectangle and those diagonals must be congruent, that means by 7.13, these are all congruent right here. And so you can take 106.5 and divide it by 2, and that's going to give you each of these. And so if I do that, I get 53.25. So that means that all of these parts of the diagonal are the same and equal to 53.25. And that's what they have for the solution there. All right, so let's look at the next example, which utilizes these properties. So for the check example, J is framing a barn door with an X brace as shown. Given the rectangle PQRS, if RT is equal to 3 and 9/16, QR is 7, and angle RTS is 65 degrees, find the following measures. There's a lot going on in this problem. So what we're going to do is we're going to draw a big rectangle in order to label all this stuff. Okay, and this rectangle is going to represent that door. All right, so this rectangle is called PQRS, and you have 2 diagonals. So let me draw the diagonal again, there, and this is points T. Okay, so let's label the stuff. It says RT is 3 and 9/16 feet. But we know that according to theorem 7.13, right here, The diagonals have to be congruent, and so each of these parts have to be the same. So that means all of these are congruent here. 3 and 9/16. This is 3 and 9/16. And this is also 3 and 9/16. Okay, well that means we can find SQ, because SQ now is going to be a combination of both of these 3 and 9/16, right? So if I add those together, I get 6, 3 plus 3. 9 plus 9 is 18, over a common denominator of 16. And remember, 18 over 16 is an improper fraction, so we need to reduce it further. 16 goes into 18 one time. So we get 6 plus 1 whole, with a remainder of 2. So we get 2/16. So 6 plus 1 and 2/16 is 7 and 2/16. But let's make sure to reduce that fraction. So we're going to divide the top and bottom by 2. And so we have 7 and 1/8. Okay, so clearly SQ has to be 7 and 1/8 feet if we combine those two distances. Now, let's do the next one. QR is 7 feet. But we know that because a rectangle is a parallelogram, these must be congruent. So this also has to be 7 feet. So that one's pretty straightforward. Now, RTS, the angle RTS, so angle RTS is 65 degrees. So let's label that. And what we want to find is angle QTR. But the purple QTR and the red RTS, notice that those add up to 180 degrees, and they're a linear pair. So we can find the purple because we know the other one. So they add up to 180 degrees. So we're going to do 180 minus 65. And that's going to give us 115 degrees. Now we want to find angle QT, or we found QTR. We want to find TQR. So TQR. All right, so in order to do this one, we note that this angle right here is actually congruent to this angle right here. And this is true for any rectangle. These two are congruent. And that makes sense because if you think about it, this triangle right here, this, let's use this color in green, this triangle right here is an isosceles triangle. And so because these two sides are the same, the 3 and 9/16, 3 and 9/16, that means that the opposite angles have to be the same, and by the isosceles triangle theorem. And so that means that if I just focus on the green triangle, then I know that the angles add up to 180 degrees, right? And so I can call this X. So let me just focus on that angle there, 115. I'm going to call these both X. And so we can see that we can add these to 180. So we got X plus 115 equals 180. So we got 2X plus 115 equals 180. So subtract 115 on both sides to get 65. Then we can divide that by 2. And we get 32.5 degrees per angle. So because these two are congruent. So TQR must be 32.5. So there's a lot going on here. Not only do we have the properties that we mentioned here, we also have the additional property that because these are congruent, this is congruent to this. And so this is important for you to recognize. So not only that, but this is congruent to this, and this is congruent to this, and this is congruent to this. Okay, so we know that this is congruent to this because of alternate interior angles. Same thing here, alternate interior angles. This is congruent to this because of isosceles triangle. And if this is a certain angle, then this has to be by alternate interior angles as well. So there's a lot going on here that meets the eye. Okay, so for example, if this angle were 30 degrees, then this angle would have to be 60 degrees because 30 plus 60 is 90. And if this is 60, this would have to be 60 here. And this would have to be 30. And this would have to be 30, and then this would have to be 60. There's a lot going on here. And then once you know these, you can of course get these angles, right? Because the triangle itself, the angles add up to 180. And so if we did that, we get 30 plus 30 is 60, and then 180 minus 60 is 120. And so this is 120. But if that's 120, this has to be 60, this has to be 120, this has to be 60. Like I said, there's a lot going on here. But never mind that. Let's look at the next example. Use properties of rectangles and algebra. So we got here quadrilateral ABCD is a rectangle. Measure of angle BAC equals 3x plus 3. So we get BAC. This right here is 3x plus 3. And then we get ACB. This is 5x minus 1. All right, so because ABCD is a rectangle, we have to have 4 right angles, right? So these are all right angles. And so that means that DCB has to be a 90-degree angle. So let's go ahead. I'm going to mark this. This is a right angle. That's a right angle. That's a right angle, and that's a right angle. All right, so we know that DCB has to be 90. We also know that because it's a parallelogram, the opposite sides have to be congruent. So this is congruent to this is congruent to that. So the opposite sides are congruent. Alternate interior angles of parallel lines are congruent. So we know that for when we're doing the alternate interior angles, we know that. So then we know that this angle right here is congruent to this angle right here, right? Alternate interior angles. So alternate interior angles are congruent for parallel lines. All right, and so we can do that. We know that ACD, we know that these two angles, we know that this angle adds up to 90, right? So that's ACD plus ACB because that's a right angle. So it has to add up to 90, okay? And then but we know that ACD is equal to this. So like if this is 3x plus 3, then this has to be 3x plus 3 as well, right? Because of alternate interior angles. And so we can say, okay, 3x plus 3 plus 5x minus 1 equals 90. All right, and we can combine those. So we get, so let's do that. So we get 5 plus 3 is 8x, and then we got 3 minus 1 is 2. So we get 8x minus 2 equals 90. 8x equals 92. Divide by 8 on both sides. And so if you divide by 8 on both sides, actually this should be 8x plus 2, not minus 2. So let me fix that right here. We got plus 2. And so we subtract 2 on both sides to get 88. And then we divide by 8 on both sides to get x equals 11. Okay. All right, go ahead and pause the video if you want to check this or if you try this before I reveal the answer. All right, so quadrilateral JKLM is a rectangle. Part A, if MN equals 3x plus 1, so this is 3x plus 1, JL is 2x plus 9. Find MK. Round to the nearest tenth if necessary. Okay, so we know that if this is 3x plus 1, then this is 3x plus 1. These are all congruent because it's a rectangle. All right, so first off, we know that this whole thing is 2x plus 9, right? And we know that MK is 3x plus 1 plus 3x plus 1, okay? Because it's the same on both sides. So far, we know MK is 3x plus 1 plus 3x plus 1, or 3x plus 1 twice, basically, right? And that's 6x plus 2. And that's MK. But we also know that MK is equal to JL, right? So MK is equal to JL. And so we can say 6x plus 2 must be equal to JL, which is 2x plus 9. Okay? And then we can solve that. So we're going to subtract 2 on both sides, subtract 2x on both sides. All right, so this goes away, you get 4x equals 7. Then we divide by 4. And so x is equal to 1.75, 7 divided by 4. Then don't forget to plug that in, right? So we want to plug that into MK. So we plug that into there. So we get 6 times 1.75 plus 2, which is going to give you 12.5. So this is 12.5 right here. Okay, so now let's do part B. It says angle JNK, so it's this angle right here. Oops, not that one. JNK is this one, JNK. All right, so this angle is 5x plus 2. And then JNM. That angle right there is 3x minus 6. But notice that this angle and this angle are a linear pair. They add up to 180. So we're going to add those up and set them equal to 180. So we got 3x plus 1 plus 5x plus 2 equals 180. And we combine our like terms. So we get 8x plus 3 equals 180. Subtract 3 on both sides, so you get 177. Or wait, let me see. Let me make sure I did the math here correctly. Oops, I used the wrong thing here. This should say 3x minus 6, not plus 1. Sorry about that. I was using this one instead of the 3x minus 6. All right, so negative 6 plus 2 is negative 4. All right, so then if I add 4 to both sides, I get 184. Then I can divide 8 on both sides to get x equals 23. Then, of course, we can plug that into here and plug that into here to get our answers, right? So we get, so let's do that over here. So J and K is 5 times 23 plus 2. And then J and M is 3 times 23 plus 2. So if, I keep doing that. I keep using that minus 6, sorry. 3 times 23 minus 6. And so if I do that, I get 117 degrees and 63 degrees. And notice that they add up to 180. All right, so let's look at the next page here. So we want to prove that parallelograms are rectangles now. So if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so basically the opposite of what we talked about. Like if it's a rectangle, then the diagonals are congruent. If the diagonals are congruent, then it's a rectangle. So it's the reverse. So let's look at that example. Prove rectangular relationships. So it says AB is 50 feet. BC is 20 feet. CD is 50 feet. And AD is 20 feet. They said AC is 54 feet. And BD is 54 feet as well. Prove that it's a rectangle. Well, for us to prove that it's a rectangle, first we have to prove that it's a parallelogram. So we can see here that the opposite sides are congruent, and therefore it must be a parallelogram. Okay, so ABCD is a parallelogram. Now, we also know, now that we know it's a parallelogram, then we notice that the diagonals are the same length, and therefore now we can say it's a rectangle. So again, to prove that it's a rectangle, first we have to prove that it's a parallelogram. The diagonals of a parallelogram. And once we prove it's a parallelogram and then we show the diagonals are congruent, then it must be a rectangle. All right, so first, prove it's a parallelogram. Let me just write it out. Prove it's a parallelogram. Then prove it's specifically a rectangle. Different ways to prove it's specifically a rectangle. You can prove that the four angles are right angles. You can prove that the diagonals are congruent, things like that. All right, so let's complete the proof. So this proof is uses the properties of rectangles. So let's go ahead and take a look at it. This one is, I'm going to go over this because it's a little bit different than the example that they provide here, because this one is an actual like proof, two-column proof. All right, so it says PQRS is a rectangle and PT is congruent to ST. All right, so PT is congruent to ST, so they marked that there. And then they said that this is a rectangle. Well, if it's a rectangle, it has to have right angles, right? And so we can see that these have to be right angles because it's a rectangle. And so that's the definition of rectangle. So the definition of a rectangle is that that those are right angles. So we're going to say angle S and angle P are right angles, okay? And why only S and P? Well, because in step 5 we have S and P there, okay? All right, and we know that the opposite sides of a parallelogram are congruent, right? And so we're going to say, okay, well, this is congruent to that. This is congruent to that. All right, and so we're going to say, okay, RS is congruent to QP. Okay, now we have RS. The reason why we're only using RS and QP and not, for example, QR and this is because we want to focus on these triangles specifically, right? Those two triangles. We want to focus on those two. Those are two right triangles, okay? So now if these two are right angles, so I'm going to get rid of these just so that we can just focus on that. So if these are right angles, then that means they must be congruent, okay? So that's step 5. And then notice that we have side, angle, side, side, angle, side. And so those two triangles must be congruent by side, angle, side. So we're going to go ahead and list those. So that's triangle RST is congruent to triangle QPT. All right, those are those two. Now, because those two triangles are congruent, that means that this third side must be congruent by CPCTC. Remember, CPCTC stands for congruent or corresponding parts of congruent triangles are congruent. So if the triangles are congruent, then the corresponding parts, these ones that match up, have to be congruent. Okay, and that is the end of the proof. All right, so let's look at the last example. So we can also use the properties of rectangles to prove that a quadrilateral in a coordinate plane is a rectangle. So there's a couple of ways to, there's a few ways to do that. But we're going to show you one way here. All right, so one way to determine whether this is a rectangle, well, first off, we have to see, are the opposite sides the same length? So remember, to determine if they're the same length, we have to use the distance formula, or you can count it, okay? So in this case, for example, we can count this and say, okay, well, how much does it go up and over? So up is 2, 1, 2, 3, 4, 5, 6, 6 over, okay? And then here it goes 1, 2, 3, 4, 5, 6 over and 2 up. So notice that those two numbers are the same, which means GH is congruent to KJ. And we can see that in the numbers here, okay? So it's the square root of 2 squared plus 6 squared. Those are those two numbers right there, okay? 2 times 2 is 4, 6 times 6 is 36. And that's how we get square root of 40. Those two numbers are the same, okay? So this is one easy way to do it. And then we have here HJ, so that's going over 1, and then down 1, 2, 3. This is going down 3 over 1. They have to be congruent, right? Because they have the same numbers there. And so we get, so notice that these two are identical, right? These are the red ones that I did. It's the square root of 1 squared plus 3 squared, right? Those are the two numbers, 1 and 3. 1 times 1 is 1, 3 times 3 is 9. So we get square root of 10. Okay, so that's the quick way of doing it, is just count up and over, and then square root of those numbers squared. Okay, that's the quick way. Now, because opposite sides have the same measure, they are congruent, and so it has to be a parallelogram. Now, to prove that it's specifically a rectangle, we have to look at the diagonals, okay? And we have to see that the diagonals are congruent, all right? So that's what we have to find out next. Okay, so if I just focus on this for a second, and I just look at the diagonals, so that diagonal and this diagonal, let's count those diagonals. All right, so let's count the length. How much does it go over? Well, here it looks like it goes over 6, and then it's really hard to tell, it should show you because there's so many things going on here, but it goes over 6. And then it goes up 5. Okay, let me see if I can draw it so I can show you. Let's do it. Yeah, let's redraw this. So we got this. I'm just gonna do this part of the drawing. Okay, and then I'll draw the diagonals. This one and this one. Okay, so it goes over 6 spaces. So it goes 6 spaces there, and then notice that it goes up like 5 spaces, or is it 6 spaces? Let me make sure I count it. 1, 2, 3, 4, 5. I'm sorry, 5 spaces, and then 1, 2, 3, 4, 5 spaces. Okay, so it looks like it goes 5 and 5. Okay, so I miscounted. So it goes over 5 and then up 5. Okay, and then let's do it for the other one. So for the other one, if you look at it, it looks like it's going okay, so it's going down 1, or yeah, so it looks like it's going down 1 and over 1, 2, 3, 4, 5, 6, 7. You see that? So it's down 1 over 7. So let me do that here. So down 1 and over 7. Okay, so if I count that. Now, if I use the formula, remember the formula that we talked about. Let me do this in blue. 1 and 7, so down 1 over 7. Okay, so in blue it would be the square root of 1 squared plus 7 squared, right? If I use those numbers, 1 times 1 is 1, 7 times 7 is 49, 1 plus 49 is 50. Then we got for the green one, square root of 5 squared plus 5 squared. 5 times 5 is 25, 5 times 5 is 25, 25 plus 25 is 50. So we get square root of 50. And so those two diagonals are congruent, and therefore it must be a rectangle, okay? It has to be a rectangle. All right, so go ahead and do the check and see if you can get the answer. All right, so let's look at the check. It's really easy if it's a lot easier if you draw the picture. So let's draw a picture of the situation, just like we had a picture in the other problem. So we got 1, 2, 3, 4, 5, 6. We get 1, 2, 3, 4, 5, 6, 7. Okay, so we got 6 and 4, 3 and 7. Oh, that's for part B. And then point A is 2 and 6. So this is what we got. And we got to figure out where D is. Well, we know that in a rectangle, this has to be a right angle, right? And so what we can do is, all right, so let's count. Let's do rise over run to see what we get. So if we go up 1 over 1, it looks like we go up 1 and then over 1. And so we got to do the same thing here. We're going to go down 1, over 1. And if I go down 1 and over 1, then that gives me 5, 3. And then notice that you get our these end up being parallel, and then they also end up being right angles here. We can see that. And so therefore D has to be 5, 3. Again, we use the fact that these have to be the same up and over, right? So D has to be 5, 3. So that's the quickest way to do it. All right, guys, that's going to do it for the video. Hope you found this informative, and as usual, see you in the next one.